So this is related to the data acquisition phase. Coming to the examination phase, we have to scrutinize the collected data in a controlled environment for indicators of compromise, and then examine file system related artifacts for unauthorized modifications, like creation of user accounts with admin privileges, or creation of new scheduled tasks, creation of some start of items, something like that. And then if any files were downloaded or modified or deleted, something like that. And then review the identity and access logs for getting the details with respect to the suspicious logins or privilege escalations, and access to the Kerberos ticketings, that is golden tickets, all silver tickets, all these things. And then check the file integrities basing on the hash comparisons, and then detect any tampering has occurred. For this thing, we can use the golden images of the disks in comparison to the live images, and we can have an idea of what type of files were changed over a period of time. And then we can focus on the changed files for deep analysis by using the golden image related comparison. So this is part of the second phase, that is examination. And then analysis and reporting. We have to correlate the findings from the logs and disks and memory to build an incident timeline, and some sort of a story building, that is a narrative. So that means what has happened, when it has happened, who is responsible, what is the root cause, and what is the scope of that particular incident. All these things we have to narrate. And then we can identify the attack vectors and tactics used, that is what is the initial access methodology, lateral movement. Otherwise, you can rely on the Maitre attack framework to identify these particular attack vectors and tactics, and then determine the scope that how many systems and which systems and what type of data and what user accounts were compromised, and if any PII information is also compromised, that also we can identify and go for a legal scrutiny. And then gather indicators of compromises such as malicious IP addresses, file hashes, domain names, usernames, all these things that were being used as part of the attack by the threat actor. And these IOCs has to be updated into the IOC databases, which the organizations should maintain. And those databases has to be integrated to the CM platform or EDR or XDR platforms, so that in future the same type of attack is not repeated, and so that we can prevent some of the identified or recognized or already faced attacks. And then final thing is reporting. Document the analysis results and then impacted assets, attacker actions, and recommendations for remediation and preservation. And these reporting points can be used as a later at a later stage as lessons learned stage, so that where during the incident attack, what gone right, what has gone wrong, what are the gaps where we can improve, what is the turnaround time to address that particular attack, what is to be done to minimize that particular turnaround time in the if a similar type of attacks happens next time. So for all these things, that is called as lessons learned phase, the reporting parameters can be used. So these are the various phases of cloud forensics. Uh, and coming to the evidence sources in cloud scenarios, commonly coming evidence sources, audit and activity logs. The cloud providers or service providers will provide logs of actions in the environment, that is through APIs. Of course, the API calls, logins, what type of data has been accessed, with respect to logins, which user accessed, from which IP address, and then what is the system identifications. All these things will be available in audit and activity logs. These will be crucial for tracking the attacker activities in a cloud service. And then cloud storage data. This is the actual content that is available in services like OneDrive, Google Drive, S3 buckets. These can reveal accessed or exfiltered files or manipulated files. And then virtual machine images or snapshots. The cloud instances snapshots will provide a complete file system and operating system level of evidence, something like a disk forensics. And we can have the installed malware and user related account activities and application related activities, security related activities, and then externally connected device related activities, if anything is there. All those particular things we can have from the virtual image snapshots or cloud instance snapshots. Memory dumps, the RAM memory, like in the disk forensics or system forensics, you can capture the virtual memory from the compromised cloud instances or the virtual machines. And these things, these malware or these memory artifacts will be containing the details with respect to malware and credentials related details. Of course, one point we have to remember in the memory related forensics is memory related forensics. Many people think that it provides a comprehensive evidential data, but please remember the memory is time sensitive. The memory at this moment may not be the memory at the next moment. So a lot of it is dynamic in nature, and then at this particular moment of time, what artifacts are lying in memory, the next moment, those artifacts may not be lying in the memory. So memory forensics gives limited set of evidences. Keeping that in our scope, we have to proceed. If we are getting more evidential materials from the memory forensics, that is well and appreciated, but not to struggle or stress that memory forensics will provide us a lot of evidential data. So this point we have to remember while conducting the memory forensics. And then metadata, the cloud metadata like instant IDs, resource creation times, and file metadatas will help link the events to resources and users. That means which resource was part of that particular incident or the attack, which user account was part of that particular account or the incident, or IP address, source IP and destination IP addresses related data, metadata informations also will provide the links to that particular attack or the incident. And then the network logs, that is network flow logs, virtual private cloud related flow logs also can be used to trace the connections and data transfers related to the incident. That is the source IPs and the destination IPs related data. And what is the size of the data that has been transferred during that particular attack. So we have already discussed the service models: infrastructure as a service, platform as a service, and then the software as a service. And here the shared responsibility model is coming. In all these particular services, in infrastructure as a service, the customer is having full control over the OS and then the virtual servers, and provides most controlled forensics, because it is something like a disk forensics concept. Whereas in the platform as a service model, customer deploys apps on provider managed platforms. So limited access is there to the operating system artifacts and then the hardware related artifacts. So he is having only access to the control, otherwise control or related to the application related activities and their logs, the customer or the subscriber. In the case of software as a service, the provider hosts the complete application, that is the service provider. So customer only controls data within the application and account settings only. So no control with respect to infrastructure, no control with respect to the application logs also will be available in this particular scenario. Only data related control will be there for the customer, because he has to feed the application with the data for processing or testing or whatever maybe. And the account related, that is user accounts who are having the privileges to feed the data to that particular application platform. With respect to that user account related settings also, the subscriber is having control. So apart from this, no other controls the subscriber will be having over the cloud service providers platform. So this is the biggest challenge in the case of software as a service. So so in simple terms, the cloud service provider's responsibility increases from infrastructure as we move to software. Coming to the forensic approach in infrastructure as a service environment, because the complete control is there with the subscriber, it provides a near equal environment with respect to conducting traditional forensics. That means we can acquire the disk images and memory. We can capture the memory from the virtual machines, similar to on-premises situations. So it is something like a complete disk forensics type of scenarios. Only thing is we have to leverage the cloud APIs for snapshotting the compromised instances for offline analysis, and host-based forensics is possible since the incident responder has administrative control on the operating systems and the platform. And additional cloud data we can have from the service logs that provides the details of actions taken on infrastructure as a service related resources. For example, if you take in the case of a EC2 instance or EC3 instance is compromised, we can snapshot its elastic block store, that is the storage volume, and analyze it with the standard forensic tools like FTK or NCase or any other forensic tool, and review the cloud trial logs if it is a AWS, where what type of calls were made by that particular instance or associated credentials or the users. So this is the simplest approach with respect to infrastructure as a service environment. And then coming to the platform as a service environment, because limited host access is there, the shift will be towards the application level logs, because applications are being hosted by the subscriber, and the configurations related to that particular application configurations also will be taken care by the subscriber. So with respect to that application related logs and then configuration related things can be managed by the subscriber, we can have the details for conducting forensic analysis. And with respect to operating system related details, because they are managed by the service provider, we will be having limited approach to that particular environment. So we can gather app service diagnostic logs in the case of Azure, and Lambda CloudWatch logs in the case of AWS. And these particular logs will be recording the application related events, errors, and then if any modifications or the injects are there from the attacker side, those details also will be having from this particular logs. And then if in some cases the app contents or the databases allow exporting the data related to the apps. For example, in the case of Azure, SQLite databases will be maintained with respect to app logs. So those snapshots related to the applications can be taken as a backup or collected, and those things can be utilized for conducting the forensics specific to that particular application related activity and the data associated with respect to that particular application. And then coming to the other points with approaches with respect to platform as a service, as we have mentioned, the service providers relying on the service providers is a must or necessary. So we can go for Azure monitor logs or AWS cloud logs, which still logs actions like deployments and configuration changes to the platform as a service resources, that is operating system related resources. But the logs are limited to 30 days and 90 days, depending on the service provider. So within that particular limit, we can have that particular logs for conducting the forensic analysis. So here the biggest challenge is we will not have any disk image from the underlying server. So we will be missing the logs, database dumps, and application telemetry. So we have to work closely to get these particular details from the service providers, that is the platform service providers. Coming to the software as a service environment, here maximum the dependency is on the service provider, and the subscribers lack access to the servers or the operating systems or the application related activities or the artifacts like application related logs also. So evidence will be coming only from the SaaS application interface and then the audit logs only. So retrieve this particular activity logs from the SaaS application if at all available. That means why if at all available? If at all they are configured and enabled and configured, and extended logging is also available. Otherwise, default logs, default times like 30 days or 90 days, the logs will be available. In the case of Microsoft 365, unified audit log records which logs user actions with respect to OneDrive and SharePoint related activities will be available. In the case of Google Workspace, admin audit logs for Google Drive and Gmail, etc., that is Google services will be available. Those activity logs can be obtained from the service provider for conducting a analysis. Use in some situations, e-discovery tools are inbuilt into the SaaS platforms, which offer some tools to export the logs and then the documents and then the emails or charts for investigation purpose. For example, in the case of Microsoft, content search and e-discovery, and in the case of Google Workspace, Google Vault will provide certain capabilities to export the documents and emails or charts for investigation purpose. Of course, we have to subscribe for these particular things. That means it is not a freely available tool. So organizations have to properly think and configure the services in so that in future, if any attack or any sort of incident happens, we will be able to easily get that particular data available for investigation and conducting the analysis. Here, one best example, case example I wanted to mention here is in one case, it is a AWS related situation. The subscriber has not opted for extended logging, and also they have not enabled the default logging. So some user by using the Gmail, some random mail ID, he has approached the organization, and the organization's contact person has provided approval to have an account in that particular cloud service platform. Why it has been approved, what made that particular internal employee to approve that particular request, which is not from a company mail ID. The request email is not from the company provided email ID. It is from a random Gmail account. What has happened, that is another issue, but that has happened. Once that was happened, the attacker was able to access the AWS platform, and he was able to change some of the configurations with respect to the cloud instances, that is the critical cloud instances or cloud virtual machines, to exfilter the data and then put that particular exfiltered data for sale over the dark web. So this is one case example where the in AWS, because of improper or the approval of user accounts by the internal employee, caused an incident for that particular organizations. Coming to the investigation, that is the after the math happened, there as I have told, the organization has not subscribed for the default logging or otherwise enabled the logging because of the cost situations for the getting the service over that particular platform. So no logs are available for that particular conducting the investigation over that particular instance or the situation. Only they are having the logs for the email logs through which the threat actor has requested to provide user ID created in that particular AWS platform, all those things. From that, those logs, that is the limited logs, are available for conducting the analysis. That is one case study. And in the case of another case study, I will give you another example that is related to Google Workspace or Google Cloud Service. In that particular situation case, what has happened is the threat actor has exploited some vulnerability in accessing the Google Workspace by a randomly created corporate mail ID. It is not a personal mail ID, but it is a corporate mail ID. But the corporate, that is the organization, has configured the for its employees to access the Google Workspace by using a two-factor authentication. That means the user once provides the email, mail ID and password, a second channel authentication will be initiated. That means sending a OTP sort of thing through to the email ID, otherwise the mobile phone. Once that particular OTP is entered, then only access will be granted to the Google Workspace. But here, with respect to this two-factor authentication, some vulnerability existed. This happened some 1 year back. During that point of time, some sort of vulnerability existed. The vulnerability was exploited, and the two-factor authentication was bypassed by the threat actor, and he was able to access the Google Workspace, and then with administrative privileges. That is the irony in this particular case example. And then once, because he was able to access the Google Workspace with administrative privileges, he created multiple user accounts with his admin privileges, and then by using that particular multiple user accounts, he escalated the user accounts to admin accounts, and by using that particular admin accounts, he tried to access critical resources, and he tried to access the golden ticket. Sorry, not golden ticket, it is a silver ticket. Silver ticket was has been tried to be accessed, and then he sent multiple emails to multiple users to reveal their user credentials in the name of service maintenance and other things. And he was able to download the one spreadsheet file which contained the user IDs and then their passwords for accessing various resources within that particular Google Workspace. So due to the vulnerability that existed in the Google Workspace, this particular attack could happen, and within in that particular scenario, approximately 2,000 to 4,000 accounts he was able to access from the downloaded credential file. So and finally, Google itself has released a patch to that particular vulnerability. Then only that particular incident could be limited or scrubbed. So this is another case example with respect to the vulnerabilities that exist over the cloud platforms. And then coming to the our topic, that is the forensic approach in a software as a service environment. We can have the metadata, and we can use the metadata analyzed with respect to version history and sharing settings, configurations, timestamps of access that will be able to indicate any malicious access or data exfiltration is happening over the particular environment or otherwise. And the main point in SaaS-based environments is the coordination and collaboration with the service providers for getting more and more information and use the security APIs to get this particular data remotely from that particular SaaS environment. So coming to the log retention, that is the, as I have mentioned, where over the various service providers or various cloud platforms, different types of retention, the default retention log retention times are there. If you take AWS, it is by default For 90 days, the logs will be retained in CloudWatch logs. But the subscriber can configure for longer retention periods, that is more than 90 days, but they have to pay for that particular thing because the logs have to be retained and stored. So for retention of the logs and then for storing the logs also they have to pay the money. Whereas in the case of Google, 30 days is the default period of storing the logs. Of course, here also more than 30 days the subscriber can opt for retention, but here also the problem will be subscription cost. And coming to the Microsoft Azure, the diagnostic logs are retained for 7 days by default, but we can archive them for longer durations. That means what we can do is to escape the cost of the subscription, the alternatives or way around the organizations can think that they can download these particular default logs, that is for the period of 90 days in the case of AWS or 30 days for GCP and 7 days for Azure. They can download and keep a offline backup and free that particular space so that at every point of time, by default, 90 days live logs will be available so that clubbed with the offline backup by the organization or the subscriber, more time period logs will be available for conducting the analysis. So this is an alternative way to escape the cost, subscription cost, and at the same point of time to have more visibility into the activities for prolonged times. So this is a way out for preserving the logs. Of course, in this case, offline backups have to be maintained on premises by the subscriber. And coming to the key differences between all these particular platforms, I think already a lot of things were discussed with respect to control of data and then evidence availability and then collection process and investigation speed and challenges. So the main thing here is the speed of investigation. In the case of SOS and PAS, it is quite slow because we have to depend on the service provider to get the logs and the other API logs. Whereas in the case of infrastructure as a service, it is very fast because everything is under the control of the subscriber. So everything is readily available. So we can immediately go for imaging the volume, setting up the environment, all these things. Of course, the another challenge is with respect to SOS and PAS. If the subscription, that is API calls, are readily available, so in that particular scenario, the investigation speed will be, that is the very high compared to the infrastructure as a service. Otherwise, it will be very, very slow. Coming to the OneDrive forensics, that means cloud storage forensics. This comes under the category. This is part of a software as a service. It is a cloud storage service synchronizing files across devices and cloud. And forensics will be covering two things: cloud side logs and endpoint related artifacts. Getting the cloud side logs for a personal users is very, very difficult task. In a corporate environment, it will be easy when they are subscribed to the service. And coming to the forensic cloud endpoint related artifacts, that means a OneDrive related artifacts from our system. In the case of personal situation, it is somewhat easy. Okay, so coming to the forensic importance, OneDrive can be used for data exfiltration or malware storage. Incidents include unauthorized file access or deletions by malicious insiders or compromised accounts. In all these particular scenarios, conducting OneDrive forensics becomes important. The evidence will be lying in user devices in the form of synchronization logs, cached files, and in the cloud, that is M365 clouds. That is the audit logs for file activities and file versions in SharePoint platform over online. So these are the various locations where the evidence will be residing. Investigations often start with the endpoint, that is the local evidence, and moving towards the cloud-based logs to have a complete picture or overall picture of the full picture of the attack or the incident. Coming to the key forensic artifacts at the endpoint, that is at the user side on the our computer or our laptop. There are various types of artifacts are there. Synchronization logs is one area, which are having ODL. You can have these ODL files at the path C users, Microsoft local, and then the OneDrive under the OneDrive logs. That is the path where we can have these OneDrive log files on Windows machine. These particular files will be recording the file operations and synchronization events. These logs will be able to show if any uploads are there to the OneDrive or downloads are there from the OneDrive, if any errors have been occurred with respect to these particular things, these synchronization logs will be providing some insights. And then trace files. These are ETL files, that is trace current.etl and trace archive.etl. These are the two trace log files, binary trace log files, which will be capturing internal OneDrive process events. That means these can be useful in low-level troubleshooting. That means if any errors are there, or if OneDrive is not properly synchronized, or OneDrive is not properly logged in, or any login issues are there, or synchronization issues are there, those things will be maintained in this particular trace current or trace files. But these trace files require special parsing, similar to the, of course, ODL files also are not easily accessible, easily parsed. We require some OneDrive Explorer type of tools to properly parse these particular files and view the contents of that particular files or the logs. And then synchronization engine databases. On a Windows OneDrive may use databases, that is file synchronization configuration or some similar to that particular configuration files that track synchronization status and linked accounts to the particular OneDrive. And then synchronization diagnostic text file will be there, which provides a verbose type of data related to synchronization operations and statuses, which can reveal what has happened over the OneDrive over a given period of time. And then local cache files, which will be keeping the copies of the various types of files that might remain on the disk, which could be recovered even if cloud data was removed. And then apart from this, registry analysis also provides some insights with respect to OneDrive configurations and then linked related information. So these are the various artifacts that can be obtained from the endpoint, and these artifacts will provide some insights with respect to these synchronization and then the diagnostic and then the cache related files and registry related evidence artifacts related to use of the OneDrive and the accounts information. Coming to the cloud side, unified audit logs, that is UAL, is the primary source of conducting the forensics, and this captures the file activities over OneDrive or SharePoint. These events or the logs will include file accessed, whether it is viewed or previewed and downloaded or uploaded or shared or deleted, etc. All these particular activities we will be having. And some of the examples are the metadata we will be able to get from the logs is file was downloaded, file was viewed, file was modified, along with the timestamps, the user account, IP address from where this that particular event has happened. These details will be having from the logs, and these will be helping attribute the actions to the user accounts. And then coming to the log retention, as we have seen in the case of OneDrive, that is the Microsoft 90 days will be the default period for which the unified audit logs will be maintained, and which can be extended to 1 year for higher licensing tiers by putting extra subscriptions. And important to export logs quickly if investigation spans longer period. That means because of this default time limited, we have to immediately download that particular logs in an offline scenario. So for conducting the analysis if the analysis is extended or prolonged for longer periods. And coming to the Azure AD logs, which provide the user-related sign-in related activities and then authentication related activities, like whether it is a successful logon or a failure logon and how many logons happened. And then if any multi-factor authentication was used, and then the IP address or if it is if the IP address is a suspicious, or the geographical location of the particular IP address also, from where the access has been performed. That information also we can have, because in some situations the user may be lying in India and the access to that particular resource, OneDrive resource, happened from another country. In that particular scenario, at that particular moment of time, the user is not possible for the user not it is not possible to travel to that geographical location. That gives a suspicion, and that marks that particular activity as a malicious activity. And then OneDrive admin reports is also there. This provides the user activity reports, which files are shared externally and which when they were last accessed. These particular details will be provided as a supplement to the forensic analysis, and they will provided not a deep information, but a high level information they will be providing. And coming to the collection techniques for OneDrive logs, endpoint collection, because the laptop or the system or the mobile device is under the control, local control, we can do a forensic imaging, and then we can go to the path, that is the OneDrive logs directory, and capture the logs and parse the logs to have an idea with respect to the synchronization, troubleshooting, and then the account related activities. And then cloud related log collection, we can use the Microsoft 365 Compliance Center or PowerShell to search the unified audit logs live. Otherwise, we can download the unified logs into an offline scenario, and you can search that particular unified audit logs by using the Excel or any parsers, PowerShell parsers, to identify the malicious activity or file related activities. And then in the case of file data or the contents, during the investigation of data theft or e-discovery or content search, exporting the files from the user's OneDrive for examination is required. This will be giving us a scope for having the data as an evidence. For this, we can use the data backup option in the OneDrive online after logging in. Of course, that requires the user credentials to log into that particular OneDrive instance. Once you are logged into the OneDrive instance, you can take a backup of the entire data that is available, and we can do a content-based search. But here we have to remember, if the data is deleted, in the case of OneDrive, 30 days the data will be present in the recycle bin. If from the recycle bin also the data is really deleted, then there is no scope for identifying the deleted data content of the data. So these are the some of the limitations with respect to analysis of the data contents. And then coming to the preservations, as we have mentioned, for the local missions, preservation is not a big challenge. We can go for a forensic imaging, and the forensic imaging will provide us a preservation related scope. With respect to cloud-based scenarios, as the data will be present by default for 90 days. Within that particular 90 days, we have to download it into offline for preserving for longer periods, or preserving that particular data for legal provisions. And if the analysis is to be conducted on the content, then taking the backup of the OneDrive or synchronizing that particular OneDrive data into a local machine is a better option. But here there are also some limitations and challenges are there. If the malicious data or the scoped data is not available, it is deleted, and it is deleted further from the recycle bin of the OneDrive. In that particular scenario, we are not having any scope to understand that particular content. So these are the various collection techniques and challenges in the case of OneDrive. Coming to the tools of for analysis, we are having commercial tools like Magnet Axiom, which will be able to directly collect OneDrive data and parse the logs and simplifying the analysis process. There are some scripts and tools are there which can be used, which were developed by forensic community, which can be used to parse the OneDrive logs and OneDrive cache databases. But these particular tools has to be tested before they are applied in practical scenarios, because of the bugs and then the parsing capabilities they show in live scenarios. And then coming to the log analysis, so we can use that is unified log related analysis. They can be downloaded from the cloud in CSV format, or JSON format, or XLS format directly. So you can use any of the format, and you can use, if they are downloaded in the CSV format, you can use the XLS tool, Microsoft XLS, for conducting the analysis by using the pivoting and other concepts, or keyword related filtering. Otherwise, you can use a CM based platform for analyzing the unified logs for various patterns related to unusual activities. So these are various tools and scopes for conducting the analysis for the related to OneDrive. So this is one of the scenario wherein data unauthorized data exfiltration happened from the OneDrive. A sensitive corporate document is found publicly leaked, available in over darknet for sale, and the suspect that an insider or attacker used the OneDrive to exfiltrate this data. And how to respond or how to conduct the forensics. First thing is detection. We have to identify the alerts in the logs with respect to OneDrive activity, something like a user has downloaded large number of files or shared a private file as a public link. These particular things we have to search in the logs, that is unified audit logs. And then we have to identify the user account involved in this particular activity. And then we have to secure that particular account, immediately suspend the login and preserve that particular data related to that user. And then we have to note down the date and time of the suspicious activity. And then we have to pull the OneDrive audit logs for that user around that incident time frame. And we have to check for final download or sharing of the events on the sensitive file, and image the user's device, that is the laptop or the computer, to retrieve the OneDrive logs, that is client-based logs, and any remnants of the file or web-related artifact, that is a browser-related artifact analysis also we have to conduct here. And then analysis portion comes to be audit logs, show the user account downloaded the confidential or sensitive document at so and so time, and then created an external sharing link, that is that activity we have to focus. Endpoint OneDrive synchronization logs will confirm the file was synchronized to the device at so and so date and time, and browser history on that particular PC will show that the user has accessed the OneDrive web at that particular time. We have to correlate this particular data and link all these particular activities to narrate what has happened first, what has happened next, and then the findings, the user's credentials which were likely used to perform the exfiltration, we have to identify, and the IP address from where the login happened will show the unusual location if anything is there. This evidence is preserved for potential legal actions or the HR related activities. And then coming to the remediation, revoking the sharing link, ensuring the account is secure, that is the password should be resetted. Investigate if the account was compromised via phishing, like email phishing or any mobile phone type of phishing or anything else. And then we have to implement the data leakage policy controls or alerts for future so that reoccurrence of that particular incident is prevented. This is a simple case where unauthorized data exfiltration over OneDrive happens and what type of forensic analysis or steps to be taken care. Coming to the Google Drive forensics, it is also a SaaS model. The forensic analysis involves local synchronization related client artifacts and browser related traces, and Google audit logs. These are the three areas we have to focus. Local synchronization client artifacts will be available from the PC or the computer the user is using, and web usage spaces or browser user spaces also will be there from the user's system. Only the cloud-based artifacts we have to see from the cloud audit logs, that is from the cloud service provider. These the incidents related to cloud drive forensics involve unauthorized access to some sensitive documents, mass data theft or data exfiltration by departing employees, and malware that is stored in the drive, so that later it can be migrated to other systems for activating the malware for linked incidents. And coming to the user context, the Google Drive, similar to OneDrive, can be accessed via a web browser or the drive of our desktop synchronization app. Both these things, that means if the one Google Drive is accessed via internet via web browser or otherwise the app, these two scenarios will generate different artifacts which will be useful for investigation. And coming to the other classification or other scenarios is enterprise level Google Drive access and personal level Google Drive access. As I have mentioned, the case that is in Google Workspace related activity, that is an enterprise scenario. We have to focus on admin audit logs and vault data export logs, if at all available, from the Google Workspace in the case of enterprises. In the case of personal Google accounts, forensic data may rely heavily on the local systems, that is on the PC or the desktop or the mobile phones. And whatever limited account info Google provides, that also will be available over the internet. That means we have to go to the settings of the user and go to the security controls and the data artifacts to see what all the artifacts are available there. That means if you see the Google lost login information limited to 10 entries will be available, those things will be used as an evidential artifact for analysis. That means the limited information will be there from the cloud-based scenario in the case of personal accounts. So these are some of the overview of the digital Google Drive forensics. Coming to the key artifacts from the local system, because we have to rely basically on the local systems. The synchronization cloud databases, this stores information in SQLite databases, like synchronization configuration database and snapshot related databases. These contain the details related to synchronized files, and then local paths, and then the cloud states, that is whether it is synchronized to cloud, whether it is available in the cloud, or otherwise it is located only in the local machine and it is still to be synchronized to the cloud, something like that. Those details will be available from the SQLite databases. And then the log files, these are plain text files with respect to all synchronized events like file creations, deletions, and modifications, and which include whether the action is local or cloud initiated. This will be revealing if a file was added or removed and by which side that particular file was added or otherwise. Cache files, which will be containing the actual files in the temporary directories. And they are having a file extension of glink or the gdoc pointing to a cloud versions. Providing the metadata, these will be mostly containing the metadata of the linked files in the cloud versions or the cloud storage spaces. And then web browser artifacts, because there are chances that the Google Drive can be accessed via a web interface or the browser interface. That browser interface or the browser history will be providing the URLs and then the files and folders that were accessed with which containing the unique identification related to that particular document or the file as part of the domain address or URL address. And then download history can show the file names and the identities of the files which are related to this particular Google Cloud related ones. So the web browser forensics or simply browser forensics will provide the details with respect to these activities related to Google Drive related file activities. And then similar to in the case of OneDrive, the Windows registry also provides some configuration related information like what is the email address of the Google Drive that is synchronized to that particular system, and the location of the folder, Google Drive folder. In the Windows registry, in the case of Mac systems, plist files will be there, which will be providing aid to identifying the Gmail addresses which are linked to that particular machine. So we can have from the Gmail address, we can conduct a OSINT related investigation to have more details with respect to that Gmail account. That is something like a name, linked phone number, something like that. So this is some key artifacts from that can be focused on the Google Drive. And then coming to the Google Drive access and activity logs that is obtained from the cloud, that is workplace drive audit logs are available for particularly and especially for enterprise related accounts only. These artifacts are available for personal accounts. These logs will not be available. And then account sign-in logs with respect to two-factor authentication also, those logs will be available. Google Vault logs will be available. Similar to the OneDrive situation. Access transparency is another special category of Google Cloud logs, wherein the Google Cloud employees will be accessing the Google workspace locations for an organization to verify whether a particular activity is malicious or otherwise, and try to intimate this enterprise or the subscriber that this particular account and this particular IP address from this particular geolocation appears to be malicious or unauthorized. Please verify and confirm. So these are called as access transparency logs. The Google staff directly will access, and then they will provide some insights with respect to the Google workspace related abnormalities. Of course, for troubleshooting of the accounts also, they will be using this access transparency logs with respect to account related troubleshooting or Google workspace related troubleshooting also. So these also will be provided by the Google service provider only. So as I have mentioned, for the personal accounts, the activity logs are very, very limited, and Google Takeout might include some activity, or one can check the account security events for device and login information. That means it is part of a overall Google activity for personal accounts. It is very, very popular. I think most of you have heard Google Takeout logs were taken in and they were used in the some sort of cases as part of evidence, all those things. But here, please remember that Google Takeout logs are having limited insights. That is one point. And then the second thing is the time synchronization issues also will be there while relying on that particular takeout logs as an evidential material. Because if you are changing the device time settings, accordingly, Google Takeout logs, that is the activity logs, Google activity logs, which are part of the location informations, and then the login IP addresses, all these things will be configured as per the device time synchronizations. So while relying on that particular takeout logs, these time stamping also has to be considered thoroughly with respect to that particular takeout logs, using them as an evidential material. And coming to the evidence collection, in the case of client-based artifacts, the system is fully under the control. So go for the traditional disk forensics, and then collect the artifacts and analyze the particular Google Drive related artifacts. In the case of cloud-based things, we have to rely on the service provider, and then we can download the data by using the APIs from the Google workspace. Otherwise, you can directly request the organizations or the enterprises directly request the Google service provider to provide their logs related to these particular Google workspace admin logs, Teams call logs, chat logs, all these things to perform to have an offline backup of that particular logs, and you can use that particular logs for analysis by using any tool like XLS or any log analysis tools also by pivoting and other concepts. So these are the collection techniques and then analysis techniques with respect to Google Drive. And then coming to the techniques, tools Commercial tools, there are two categories of tools are there. Google Drive forensic scripts are there, open source one. While using these scripts, we have to thoroughly test the two scripts for their veracity. Otherwise, you can go for the commercial tools like Magnet, Axiom, Cyber. Those can be able to pass the drive synchronization data, and these tools can decode properly the SQLite schemas into which the log data will be stored in the local systems. And then in timeline reconstruction, we have to combine the local timestamps and then the cloud audit log stamps to build a complete picture of the activities related
ఇలా
to
చాలా
file event.
మంది వేయాల్సినవి రేపు కూర్చోబెట్టాలి. నువ్వు సగం వేసుకుంటా నేను సగం పైన వేసుకుంటా.
And then we can identify the data exploitation based on the audit logs by checking for patterns like download events and share events sort of things. And then we can use the keywords like IP addresses and identify the foreign IP addresses or malicious IP addresses to identify any related to any activity related to data exfiltration. And then email and chat related artifacts also can be obtained from the Google service provider to see activities related to any phishing emails or Gmail related access, or the user has shared any files through Gmail accounts. And coming to the open source tools, G's Seller or Google's own forensic utilities are there, which may be helpful in download the logs from the Google services. And commercially, tools like Cado Response is available to automate the GCP and workspace evidence collection across logs and storage. So these are the various tools and that can be used for conducting the Google Drive analysis. Coming to a scenario like suspicious file sharing, a company discovers that a confidential folder in a Google Drive was shared with an external Gmail address without authorization. So what will be the workflow or walkthrough? Detection is admin receives an alert, the Google Drive admin, for an unusual external share. We have to focus on that particular alert. And any DLP is installed. The alert triggered in the DLP
13వ తారీఖు
platform
వరకు
also
వేసేసా. ఫస్ట్
there.
స్టార్టింగ్ ఏం చేశాను,
Then scoping
మధ్యాహ్నం
identify
వేసేసా
the users who owned the folder and the time
తెలిసిన
when
వాళ్ళకి
the folder was
మన
shared,
కాలేజ్ వాళ్ళకి
and we have to confirm the scope,
వేసేసా.
which files were there in the
లోపల
folder
అయిద్దిలే.
and who are having the
ఇంకా
accessibility
ఆ
rights to
తర్వాత
that
ఈ
particular
రోజు
folder.
మీటింగ్ లో ఎవరైతే కనపడుతున్నారో ఏంటి మైకు, నా మైక్
So move చేస్తారండి.
ఎవరు ఆఫ్లో.
And then we have to pull the Google Drive audit logs from the cloud for searching for the items like item shared, and find the entry like who is the responsible for sharing the particular folder with any external user like with Gmail, on what is the date and time when it was shared. And then after that, if any file download activities were observed for that external user for various files present in that folder, we have to find that particular logs and save that log records. And then the personal laptop or the system of the end user has to be obtained and conduct a forensic imaging. And then we have to obtain the drive synchronization logs in a normal forensic analysis, traditional forensic analysis. And browser forensics also has to be conducted on the system, on the forensic image of the computer system. So this is the another step to be taken care. And then after conducting the investigation, we have to prepare a story or the walkthrough of the activities that have happened, and we have to provide the report in that particular scenario. And coming to the AWS Cloud Forensics, what I will do is I will skip some of the slides because we are having a very limited time. The major key forensic artifacts are the logs with respect to AWS is AWS Cloud Trial logs are the primary audit logs which are used for analysis. Apart from that, CloudWatch logs are there, which will be containing the application logs from the AWS Lambda. It is a service, and server logs also will be part of the Google CloudWatch logs. Virtual private network flow logs also will be there. These will be plot for the CloudWatch logs, and these provide granular, that means minute information with respect to the activities. And then bucket access, that is S3 access logs also will be there. AWS configuration logs are there. EBS snapshots, so that is the disk images, that is the Google instances disk images you can take over the AWS platform itself, the snapshots. And then the memory capture also will be possible over the AWS by using the inbuilt tools. And other logs are identity and access management cloud trial logs. All these are the various forensic artifacts or the logs that has to be collected for conducting a in-depth forensic analysis in an AWS type of scenarios. But basically, cloud trial logs are mostly used with respect to other things. The subscriber has to subscribe to that particular service and enable that particular service. Then only those logs will be available. Otherwise, those logs will not be available. So that is the major challenge. That means pre-configuration, pre-enablement of these particular things are required. Otherwise, after the incident happens and these are not pre-enabled, you will be people will be missing the crucial artifacts from this particular logs. Coming to the AWS log retention, as we have seen, by default logs are retained indefinitely, that is CloudWatch logs. However, you can customize the retention period for each log group ranging from 1 day to 10 years. And in the case of S3s, the logs for access to the buckets can be lifecycle policies applied to manage retention. This allows you to have the transaction logs to cheaper storage classes or delete them after a specific period. So that means you can configure these logs for a certain period, and these logs can be pushed to another bucket storage space for a specific period, configured period, that is like 30 days or 60 days or 90 days. Once they were pushed to a storage space, from that particular storage space, you have to download them offline for offline preservation, making that particular storage space available for new logs. And then cloud trial logs are retained indefinitely by default, by default, ensuring compliance and audit requirements. You can also configure them to be stored in a S3 bucket for longer time term retention. So these are the various log retention policies for AWS. Coming to the cloud trial related logs, um, you can major points only I will be focusing. These can be this event history will be allowing you to view and search and download the past 90 days of activity in your AWS account, and within 15 days the logs will be delivered with respect to account activity. These are the major points we have to see remember with respect to cloud trial logs. And the anatomy of a Google trial log event will be like this. So from this, what sort of information or inference we can get is who made the API call, that is user identity, something like the event time, that is the at what date and time the API call was made, and what is the type of API call, whether it is event name and start instances, which instances were started, and then which resources were used in this API call. Something like instance ID will be there. From that particular ID, we can identify which instance was accessed, that is the resource was accessed as part of that particular event. And then from which what source IP this particular API call was made, that also we can have, and what is the region from where this particular call was originated, that AWS to which AWS region that request was made, that also we can have from the Google trial event. So we can make a story from this particular trial event that the identity and access management user with username alias made a call to US East 2 region, that is Oregon, that is the geographical location, from the source IP to 205, like that. By using the user agent EC2 API tool, the API call was made at so and so date and time. The name of the API call was start instances with the parameters instance set, and then instance ID is so and so. That means this particular instance was to be set to be started, and then it was accessed on this particular date and time. And then CloudWatch logs are another things which contains application system log files from the resources part of this particular CloudWatch logs, as we have seen in the previous slide. So I am not going in details with respect to CloudWatch logs. And these are the various steps for collection the logs. That is isolate and snapshot the instances, and then log has to be retrieved. CloudWatch logs snapshot analysis has to be performed, memory capture to be done, and then memory related forensics has to be completed, and then the memory forensic artifacts has to be obtained to have more insights. Preserving the AWS metadata is another step. So coming to the tools for this analysis, for log analysis, CloudTrail is often the treasure trove, and for this particular thing, we can use tools like Athena and then CloudTrail Lake, which can be used for conducting the forensics. And all the CloudTrail Lake is part of the AWS platform, and you can use that particular AWS platform for conducting the forensic analysis. With respect to disk analysis, the traditional disk analysis tools can be used like Magnet Axiom or FTK and other things. And network forensic analysis, we can use the Excel or CM based platforms for conducting the analysis. And then there are some AWS specific tools are there like AWS IR scripts, which will be able to automate the tasks like snapshotting instances and gathering key data, which will be able to speed up the evidence collection. And then AWS also provides an IR guide and scripts for best practices. So we can go to that particular IR guide to have that particular details. Otherwise, we can rely on the platforms, online platforms like SWGDE, that is Scientific Worker Group on Digital Evidence. That platform you can go and have the documents, that is the process documents or workflow documents related to collecting the forensic artifacts from the cloud-based platforms and then analyzing that particular data that has been collected. That is one of the best platform to have the process documents. And for memory forensics, we can use the memprocfs or memprocfs analyzer or volatility or recall for conducting the memory forensics. Then Azure cloud-based forensics. If you see, these are the various key artifacts and logs, that is Azure activity logs, Azure AD logs, and then resource logs, that is the diagnostic logs, which contain the something like OS related logs, and then the event logs, sys logs, monitoring logs, all these things. And then network logs, they will be containing the network flow logs, and then the which contain the source, destination IP addresses, ports, and other things. And then virtual machine disk images. In the case of AWS, the AWS itself is containing a inbuilt capability to create the snapshot. Similar to that particular thing, in Azure also, we will be able to create the VHD files in Azure storage, and the snapshots and also can be created with inbuilt capabilities, and those things can be used for conducting a traditional disk forensics. And memory dumps, coming to the memory dumps, in AWS there is a capability is there to capture the memory of the virtual machines, but in Azure there is no such capability is there. Only capability is there, you have to install a memory capturing tool, that is like FTK Imager or dump it type of tool into the virtual machine directly, and it has to be executed in the virtual machine to capture the memory of that particular virtual machine. That is the way around for capturing the memory dump. And then Defender logs or Defender alerts are another thing, or Sentinel logs are another resource or the forensic artifact that has to be collected as part of conducting the Azure forensics. So coming to the retention, data in log workspace will be retained for 30 days for by default, but we can configure for 4 days to 730 days, that is 2 years. with subscription modes or licensing modes. Azure provides a capability for 12 years of retention and archiving at a lower cost compared to AWS. And these particular logs can be immediately available for querying or conducting a threat hunting or threat intelligence, and they can be restored when as and when required. And then custom retention, that is more than 12 years if you are looking, and accordingly you can configure the data management by using the subscription modes. Coming to the free tier limitations, for free if it is a free tier type of scenario, the subscription for 7 days only, the logs will be retained, and if you are looking for more number of days, we have to pay for that particular tiers. Coming to the analysis tools, similar to AWS, we are having various open source tools based on Python and Azure SDK. Something like Azure Forensic Tools is there, but the scripts before, with respect to open source tools, the main concern is before they are practically used, we have to test them properly, and then only we can use all those particular things. Otherwise, the commercial tools are available, for the log analysis, the CM and EDR platforms are unavailable, or Sentinel-1 provides that particular capability. For the disk analysis, the traditional disk forensic tools are available. So these are some of the concepts with respect to conducting Azure forensic analysis. Coming to the GCP, the unique tools, the process will be more or less, so I am not going in depth into that particular processes. The tools will be Turbania, which is an automation framework for cloud DFIR, and DF Time Wolf or Google Cloud Forensic Pipeline. These are the some Google-based unique forensic tools for processing the evidence and then the conducting the forensic analysis. Coming to the log retention, the default time will be 30 days, and you can increase this by using the subscription tiers, and the retention period can be extended up to 10 years by configuring the log buckets, and then the archived logs can be exported to the Google cloud storage and BigQuery for long-term retention and conducting advanced analytics, and then audit logs will be retained for 400 days for by default, while the data access logs are retained by 30 days unless exported. That means if you are exported and making it vacant, then another 30 days logs you can have. So that type of scenarios will be there. So these are various concepts and things related to Google Cloud, cloud-based forensics. Some of the best practices will be, we have to have forensic playbooks if any incident happens, to conduct a analysis, that is a walkthrough or the steps involved into that particular analysis. In the case of a compromised cloud-based virtual machine or a suspicious O365 account activity, then the teams or the security people can have a ready-made step-by-step process to be taken care, because it is very complex in cloud-based scenarios, and they are still not matured, because the cloud-based scenarios are always developing and new type of capabilities are being added. That is the biggest challenge in conducting the cloud-based forensics. So always having a forensic playbook and then updating that particular playbooks whenever the new capabilities are being introduced into the cloud platforms. That is the best way to address this particular complex and dilute ambiguous scenarios, that is cloud scenarios. And then we have to preserve the forensic tools also readily, and accounts have to be created. That is forensic accounts, creation of forensic accounts and maintaining the forensic accounts in the Google in cloud platforms is best way, so that by using the forensic accounts which are maintained in the cloud platform, directly you can act with administrative privileges and audit privileges. You can directly access the various resources within the cloud platforms to get readily the artifacts, forensic artifacts pulled and then conduct the analysis. That is one another key point that has to be taken care into care. And access control for investigators, that is the for the forensic accounts, as I have mentioned, extended privileges has to be there, or elevated privileges has to be there. And then collaboration with cloud service providers is another important task, because in the case of SaaS or PaaS, the association with the cloud service providers is the key point in getting the relevant evidential artifacts in the minimum possible turnaround time, so that we can start investigation and get the results in a minimum turnaround time. And then training and drills, because the, as I have told, cloud-based scenarios are dynamic in nature and new features are being added every here and there. Training is one of the best concept, and we have to conduct some security drills also with respect to focusing on the cloud-based incident response tasks. So these are some of the best practices and principles which can prepare people ready in safely tackling the Google related, cloud based attacks or the incidents. And then the best practices, these are general best practices for data protection and integrity in digital forensics. Preserve the evidence in integrity by using the hash values, use immutable storage devices, and then chain of custody has to be maintained if any legal aspects are involved. And then segregation of the duties is a must, because yeah, all the people involved should not do the repeated tasks. Here the tasks or the duties has to be segregated, and then we have to see that necessary documents, playbooks or workflows are available to that particular team, and then they are following, equipped with the necessary tools also for collection, preservation, and analysis. And then retention and storage is another task with respect to cloud for in the cloud forensics, because limited time logs are available. So for keeping that retention period, log retention period in view, those things has to be properly stored offline for prolonged investigations or analysis. And then lessons learned and reviewing is another step, best practice. After the post incident, it is a post incident activity as part of a lessons learned process. We have to identify the gaps and improvise that particular thing, gaps club for so that in future similar type of attacks are effectively tackled or prevented at least. And then these are some of the open source forensics tools for cloud. Log2 timeline and Plaso is one tool which is basically used for log analysis. Sleuthkit and autopsy, which is used for memory forensics, of course. And then the disk related forensics, browser related artifact forensics, registry, Mac based artifact analysis, all those things. And volatility is a primary thing for memory forensics. Basing on the volatility, there are GUI based tools are available, like Volatility Workbench, memprocfs. Memprocfs Analyzer is the automated memory forensic tool, which is very vastly used nowadays. And then Google Cloud Forensic Utility is another thing. AWS IR Toolkit, and then Kubernetes forensic toolkits are there. These are some of the open source forensic tools for conducting cloud forensics. Coming to the cloud commercial forensic tools, CADO Response, Magnet Axiom, FTK, NCase in cloud, and then Azure O365 e-discovery, and then the DFIR ORC cloud specific scripts. These are some of the commercial tools which can be used for conducting the cloud forensics. So these are some of the key takeaways. Cloud-based forensics is an extension of the incident response and disk forensics, which brings with, new challenges. And at the same time, we are having event-rich, content-rich events or the logs when pre-configured only. And then the preparation is the critical task. That is pre-enabling the logs is one preparation stage. And then we have to have some playbook, that is a process in place, how to tackle a particular incident in the cloud. And then with respect to the different platforms like AWS, Azure, and cloud, or otherwise storage, software as a service like O365 or Google. The core forensic process will be the 4 steps of NIST, that is identify, collect, analyze, and then report. Those are common, and we have to focus on that particular 4 stages of the NIST digital forensic processes. And then we have to be equipped with the right tools for collection, preservation, and analysis. And then the cloud native features are there, like in AWS, capturing the memory, capturing the snapshots of the VMware, and similar in Azure, capturing the snapshots of the VM missions, and similarly in the Google also. Those inbuilt tools, leveraging the inbuilt tools is also a way out for completing some of the tasks. So these are various key takeaways from the cloud-based forensics. These are some of the future learning and resources you can go for having more information with respect to cloud-based forensics. So this is all about cloud-based forensics. If anything or any points are there, you are welcome. So we can jump into the next, that is mobile phone forensics. So if no questions are there, I will jump to the
Yes.
mobile phone
Sir,
forensics.
shall we conclude, sir? It is already 9
Yes, yes, sir.
completed.
Only with respect to mobile phone forensics, sir, I wanted to give you for a few inputs.
Yeah, sure. Sure, sir. Sure. Yeah.
So in mobile device forensics, 3 phases will be there: on-site evidence handling and preservation, and forensic lab acquisition, forensic image analysis, that is locating the artifact. These are the 3 phases. Coming to the on-site handling, that is the golden hour, it is called as. It is very, very critical, and any mistake can render evidence inadmissible or
There are
destroy
any
the
queries
particular
they can
evidence.
ask.
Yeah. And then the process will be photographing the device as it is found and noting the power state, that is whether the mobile phone is in on condition or off condition, basing on the screen content and all physical connections. Immediate network, we have to immediately isolate it from the network. It is the highest priority. For this thing, we can use the Faraday bags. Otherwise, if you are able to access the various artifacts or scroll to the various artifacts of the mobile phone, you can choose for aeroplane mode if it is unlocked, and manually confirm Wi-Fi and Bluetooth are also off. And then we have to establish a chain of custody immediately for legal process. And most critical decision comes from before first unlock and after first unlock. This is because in modern smartphones, they use a file-based encryption, that is the FBE called as. Depending on this depends on the power state and subsequent actions. What is before first unlock means if the device is in powered off mode and it is just rebooted, all user data will be present in fully encrypted and it is not inaccessible. Sorry, it is not accessible. So if the phone is found to be in off condition, do not turn it off. Turn it on. That is the action to be taken in this particular case. If you powering on could trigger locks or a remote wipe. What happens is if you are powering on the device and using the wrong credentials to unlock that particular device, then what happens is there are chances that it will trigger a remote wipe or it is permanently locked. That is called before first unlock. And if your phone is found in this particular BFU mode and you are not having the access credentials for that particular smartphone, you can leave that phone that no data is obtained. No evidence could be retrieved from that particular mobile phone. So BFU is very, very critical stage in mobile device forensics. AFU mode after first unlock. That means when you are finding a mobile phone which is in switched on condition Of course, the device may be locked in the locked condition. Okay, that means the decryption keys are available in the volatile memory of the mobile phone, that is in the RAM of the mobile phone. In this case, you should not turn it off. If you are turning this particular mobile phone off, it will be going into the BFU mode. So you should not turn the mobile phone into off mode, and then you have to place it in a Faraday bag and immediately go for a analysis or collecting the data from that particular mobile phone by use. If you are having the right credentials for that particular phone, that will be very helpful. Otherwise, you can use some commercial forensic tools to conduct a forensic analysis and retrieve the analysis. Of course, here also there are some challenges are there. And then coming to the forensic lab acquisition strategy, that is the phase 2, we have to choose the tool, and then basing on that particular operating system version, that is iOS version and Android versions, we have to identify the right tool to bypass the security patch level and then get the data retrieved. So here the challenges will be identify device model, that is OS version. If the iOS version is 17.4 and above, and Android version is above 14 and above, then and the security patch level is latest one, then it is not possible to be conducted for forensic analysis. And if these conditions are met, that means they are below these particular conditions, then you can use commercial tools like Celebrate, UFED, MSAB, XR, or Magnet Axiom to pull the data and perform the analysis. And coming to the challenges with respect to iOS 17.4 plus 1, as of mid 2024, forensic tools reportedly cannot unblock BFU devices running 17.4 or later due to patched exploits. This makes capturing a device in the AFU state essential. That means if the iOS is in the BFU mode and it is having 17.4 plus version, then you can take it granted that it is not possible to conduct any forensic analysis on that particular iPhone. And then hardware attacks are there, JTAG and chip off. These also will be coming as part of the embedded system for embedded forensics. These will be futile against modern hardwares like Apple Secure Enclave. The decryption chips are physically isolated and cannot be extracted from the memory chip, because the security chip is separately. Previously, the security chip and the memory chip are present in the same one chip, but now they are segregated. The security chip is separate, and then the memory chip is separate. And if you are going for a JTAG or chip off methodology and you are retrieving the memory chip only and you are leaving the security chip behind, then the memory chip contains the entire thing is encrypted and you will not be able to decrypt that particular data. And if you are able to extract the security chip and there will be missing a bus between the security chip and the memory chip for automatically generating the decryption keys. So that is also very toughest task. So hardware attacks are also not possible in these particular scenarios. So these are some of the challenges. And then coming to the what is possible, what is not possible with respect to the mobile phones nowadays. Logical extraction is one method, wherein please remember the proper user credentials are known, then only all these things are possible. Otherwise, it is very difficult or it is not possible. In the case of logical extraction, what type of data is recovered? User accessible files, that is photos, contacts, and similar to iTunes backups, the data can be recovered. And then it is suitable for crypto investigation. This is insufficient because the logical data will not provide the data from these particular areas, because the protected wallets or databases and the files or deleted data will not be available for conducting analysis in the logical extraction methodology. In the physical extraction methodology, it is something like a bitstream copy of the raw memory chip, and this is also not feasible on modern devices because the data is fully encrypted due to the FBE channels. So the mostly preferred methodology of extraction from the data from the recent smartphones is full file system analysis, which is a extrapolation of logical analysis, logical data extraction, which includes protected apps, directories, system logs, and databases. And this is required and the minimal viable method for the achieving the true objective of conducting the analysis, wherein the protected databases also can be obtained along with the decryption keys. So though these are the challenges and the methodologies that can be used in the phase 2. And coming to the phase 3 analysis of the image, the hunt for artifacts. Once the full file system image is acquired, the analysis will begin. We will be focusing our analysis on phone book entries, call logs, SMS messages, social media conversations like WhatsApp, Snapchat, Telegram, Facebook, etc., etc. And then browser related artifacts, that is the normal browsers, Google browser or Edge browser or any other browser, and specific to dark web browsers like Tor and Onion related routings analysis. And then financial applications related analysis will be conducting the like crypto wallets, apps related data. And coming to the challenges with respect to social media apps, with respect to WhatsApp, the challenges are view once related, view once type of messages, and then encrypted backups are the challenges, or deleted WhatsApp messages or by default with after 24 hours or 1 day or 7 days or 90 days the back messages are deleted. Those are some of the challenges. What is the way around is before the message is opened, if the backup happens locally, in that particular scenario, you will be having the deleted messages also as part of the backup, and you will be having a evidential material. If the message is once opened and no backup is taken before the message is opened, then it is gone forever and the deleted messages will not be obtainable. Okay, this is one WhatsApp related challenge. So coming to the snapshot related things, unopened snapshots are auto deleted after 31 days. That is one-to-one type of messages. If it is a group message, after 7 days they are deleted. And here also the concept is, if they are taken as a backup, then they will be available. If they are not taken backup, they will not be available. And then in the case of Instagram, vanish mode or disappearing messages are there. There also, once the messages are viewed, they will be lost. But saved items are available for analysis and providing as an evidential material. In the case of Messenger also, vanish mode was depreciated, but disappearing messages were existed. Messenger now supports end-to-end encryption, charts with optional secure backups, and these are available on the server side, not on the client side. So getting that particular data from the server side is the biggest challenge. For Signal, the servers does not hold anything and no message content is obtained, and recovery of hinged or device acquisition or users local encrypted backups will be available. And from the encrypted backups, it is very tough task to get the plain text messages or conversations. Similarly, we can see Telegram challenges, Apple and cloud challenges. I think you can read it out so that you can have the challenges. So this is all about the mobile phone related forensics. So now I think I tried to cover or give you an overview of various things like mobile phone forensics, cloud forensics, and network forensics. I am not having much time now to give any overview with respect to the embedded system forensics. But embedded system forensics is something like a JTAG methodology extraction or a chip of related extractions. But there you can see the challenges as I have told in the mobile phone forensics. Apart from that, with respect to embedded system forensics, logs play crucial sources of evidence, because the embedded systems or the IoT devices maintain a lot of logs on the server side, of course, and limited logs on the client side within the available storage space in the micro SD cards. So from the micro SD cards, you can have the logs for a limited period, but on the server side, you can have the logs for an extended period. So getting the logs from the cloud side and then the that is the service provider side, and then the local side, that is the local storage side, will give us a complete picture of that particular IoT related forensics. So this is this point I wanted to give you an overview of the IoT related forensics or embedded system forensics. So with this, I wanted to conclude, and the next 15 minutes, if you are having any doubts or questions, please feel free to ask the questions. Thank you.
Yeah, participants, if you are having any questions, you can ask. Yeah, sir, I think we can conclude the session, sir. So we are happy that we are having a lot of insights regarding all the three platforms. So, sir,
Main challenge with respect to these topics is that it is not possible to have the sample data and then show some
yeah,
demonstration of the tools. That is the
yeah,
biggest challenge for this particular sessions. Only we will be having a theoretical overview of these particular things. And
yeah,
what I am
I
doing
understood,
is,
sir, because over your overview, initially I have mentioned as a practical exposure also. But with your session, I have understood that it is not possible to have a data set like thing. So it is all everything systems related.
yes, sir. And I have shared one website,
Yeah.
SWGDE, what I have mentioned. This is
Okay.
the primary resource, scientific working group on digital evidence. This is the primary online resource where various types of documents are related to workflows and conducting forensics and collection of the data from various resources. You can see the current documents. That is one thing. And another resource is there. I'm not immediately getting the resource title or name. I will share that particular thing over the WhatsApp channel.
Yeah.
That can be helpful for you.
Yes. Please share any useful information, sir. I'll just forward the same to the participants. We are having already a WhatsApp group for the participants also.
Yes, sir. Yes, sir.
Any insightful information that you feel to share, you share with on my personal chat, sir. I'll definitely forward the same to the participants.
And these presentations also I will share over the channel so that
Yeah,
you can.
people are asking, sir. People are
Yes, sir.
asking. They will have
Because
that
it
will
is
be very
mostly
much useful.
theoretical. So
Yeah.
keeping that aside, you can have the data thing, and then
Yeah. One thing is, sir, any simulation environments will be there to have the expertise on all these what we have discussed. In an integrated
simulation
simulation environments are there.
simulation environment. I think some limited resources are there for these things. I will try to share them over the WhatsApp channel.
Yeah.
Um,
Good evening, sir.
Good evening.
Sir, sorry to interrupt you. Sir, do you have any personal WhatsApp channel so that we can follow?
I am not having any personal WhatsApp channel, madam. I am having a broadcast channel wherein I share the some of the things like opportunities and then some technical know-hows to my students, and then students in the sense in as part of my work, various people work under me. Babu Subramani also worked with me. He's some
Yes.
few years back. So with him and other people, I will use to share the technical know-hows and then the opportunities, some contents, all those things. So that is the broadcast channel. I don't want to have a group, and I'm unable to maintain the group also. Only broadcast channel I am having. I have shared one other
Okay, can we
website,
also
sir.
join?
Security event logs related encyclopedia. This is one good online resource to identify the security events. I think another thing is I wanted to I'm not having much scope. Otherwise, if you give me 5 minutes, I will demonstrate one tool with a set of event logs, that is APT Hunter, because event log analysis is one of the crucial one. If everybody agrees, then only I will go for the demonstration. It is a small demonstration only. Otherwise, I will skip that particular demonstration.
Yes, sir. If anybody, if interested, Madam Sarita, Madam, shall we move forward for 5 more minutes?
I'm sharing my screen.
Yeah.
Yes, sir. Yes.
Just for event log analysis, I will show a small demonstration, and I will show the online resource also. First, I will show the online resource, that is APT Hunter. This is one good tool for conducting the event log analysis. You can download it from this GitHub resource. I'm sharing the link in the chart. So what I will be doing is I am going to my APT Hunter tool, and I'm having a sample logs from the Windows machine collected. These are the various EVTX files. On this particular logs, I will try to demonstrate this tool. Normally, what I will do is I will prepare a command line, because we will be using some n number of tools as part of our practice. So the command what should be used also, I try to keep it in a text file. So this is these are various commands that can be applied for the APT Hunter on the logs that were collected. Now, uh, the simple tool is processing the EVTX files, and then I have to give the path where the event log files are available.
So can we also get the video link of this?
Pardon?
So is the video get recorded? It got recorded, sir. Can we also get
Yeah,
the
it
Yeah,
is
yeah,
video?
getting recorded, madam. It is
no
getting
problem.
recorded, madam.
It's recorded.
We'll find out the way to share it. We'll maybe keeping it some kind of drive, and we'll share the link. But it is not immediate, madam. Once it is done, I will share,
Okay,
because it is these are huge
okay, sir.
files. First of all, we need the storage, and then only share the link.
Okay, sir. Thank you.
This is
Yeah,
a
but
simple
every
command.
session is recorded. But every session is recorded. Yeah.
This is the simple tool, simple command you have to use. And if you are using a Sigma-based analysis or ARA-based rule analysis, you can use accordingly the Sigma rules or the ARA-based rules. But this particular simple command is sufficient. Once we execute this particular command, it will automatically analyze all the event logs, and then it will provide a output into the same folder from where the APT hunter is running. And while conducting the analysis, some errors also will be occurring with respect to the configuration of the APT hunter tool itself. Because Python related configurations, in the latest version, some Python related configurations and other challenges are there. So here you can see the output, number of incidents by detection rules, and then number of incidents by severity, medium severity 1397, high severity 287, critical 77, low 38 events are there. And basing on the suspicious incidents, that is the detection rules, suspicious PowerShell commands are detected 1133, PowerShell script blocks, suspicious PowerShell commands 330. Defender anti-malware platform configurations were changed, that is either it is switched off or disabled, something like that, 125. And PowerShell pipelines suspicious commands 84, something like that. Some sort of metrics we will be having. And you can go to the same folder from where the APT hunter was there. A results folder will be there, and under that you can see all the various artifacts that were collected. This is the main report, that is results report is the main one, where you can see the filtered out events, because from all these particular events, that is the event log files, what I have chosen, these log files, these are various log files. You can see the sizes of these particular log files. Approximately these log files will be running into some 1 lakh or odd logs. Out of that particular 1 lakh or odd logs, this APT hunter tool has filtered out the suspicious events into this particular 2000 or so. So now we have to manually analyze this particular logs. That means these tools will provide us a way out to limit our scope of analysis and then focus on the suspicious events only. So this is one tool, APT hunter. Then another tool is Hayabusa. Where is it? This is the Hayabusa. This is another tool, and I will be just a moment.
So sorry to interrupt you. It will create only current log. Is it for how much duration, sir? Is it for 1 week, 1 month, or since what time it will create this suspicious log?
In this particular demonstration, I have collected all the event logs from my system. Okay, and that is offline, not on the live machine. And those logs
Okay.
are ranging different logs are there. There are approximately 300 odd logs are there from my Windows. These are from my Windows machine only, and these are ranging from
Yes,
30 days to approximately 1 to 1.5 year or so. There is no time limit is there.
Okay. Okay.
So this is another GitHub repository, Amato Security Hayabusa. You can download the latest version 3.60. I'm having in my presently 3.30 only, but the current version is 3.60. And what you can do is you can go to this is a very good site with the examples, command line examples also. Where it is? Scroll down. Yeah, here this thing, command uses. This gives complete picture of how to use this particular Hayabusa tool for conducting various types of analysis tasks on event logs, particularly Windows event logs and then the Sysmon event logs. This is another thing I wanted to share with you. And then coming to the memory forensics, I think, sorry. Mempof Analyzer. This is an automated memory forensic tool. Of course, this particular tool was built over volatility framework calls, of course, but it automates the entire memory analysis process. This website also, what I will do, I will copy paste into the chart. Where it is. And then the Hayabusa related here also. So these are some of the resources for conducting the event log forensics. Major thing is some sample data is also available for log analysis in the Hayabusa. You can use that particular sample data for conducting or practicing this particular tools. That is one suggestion I can give you. So this is all together with respect to event log forensics and memory forensics. So any other points are there? Please, I think we are crossing the time also.
Thank you so much, sir.
And
It was very informative. Now we have learned a lot. I think we have to learn still more. Thank you so much, sir.
I think Babu has given you an insight of how the security operations in an organizations are conducted. There will be three layers. Uh, in short, security operations center is one area, one team. Incident response team is another thing. Digital forensics is another team. In security operations centers, level 1, level 2, level 3 analysts will be there. And security operations centers will be having the security platforms installed, something like Splunk or Wazoo, that is open source. Otherwise, a Sentinel-1 or Defender or CrowdStrike or CyberReason or any other platforms, Palo Alto, Cortex, something like that. The level 1 analyst will be working around the clock 24/7, and they will be the platforms will be configured to identify the alerts and categorize the alerts in critical, high, medium, and low. And there will be policies that the L1 analyst has to focus on critical, high, and medium level alerts and verify that particular alerts for their true positive and false positive nature. And the L1 analyst will be escalating that particular findings, true positive or false positives and the alerts to the second layer, that is L2 level analyst, and L2 level analyst will conduct the same process repeatedly, and then they will confirm whether they are false positive or true positive with their comments. And then once again, the process is escalated to L3 analyst, wherein the final output will be taken care, that is whether it is a false positive, and that alert has to be marked as not as a false positive, or it is a true positive. If it is a true positive, then immediately that will be escalated to the next team, that is incident response team. And normally incident response teams and digital forensic people work together. But for a clarity, I'm saying how the teams will be constituted. The incident response team immediately jumps into the situation, and they will be collecting the logs from the security platforms, so CM, XDR, EDR, all these platforms, and they will do two types of analysis. Offline analysis, that is download the logs and conduct an offline analysis by using the XLS or pivot, and then pivoting. And then the second type of analysis is over the platform itself, they will get some read-only access to the logs or the platforms. And on the online platform, they will be conducting an analysis. That is the second category. And coming to the digital forensics, if at all any deep dive forensics or disk analysis, disk forensics or browser forensics or any other type of analysis works are to be dealt with, the digital forensic team will be coming into picture. In short, this is the arrangement of the teams as part of a security operations in an organization. So I wanted to give you this particular overview also. Okay, thank you very much for these 3 hours being with me. Of course, mostly theoretical. Some demonstration I have planned in the last. I am able to show you that demonstration also. Thank you very much. If
Yes,
anything is
sir.
there,
Thank you
please,
very much for your,
your
thank you very much, sir, for your insightful session. And you're having abundant knowledge, which cannot be limited to a 3 hours. We'll definitely have more sessions in future, sir, by different means or different platforms. So thank you, sir.
thank you.
Thank you very much for your patience and strength for giving the knowledge to all the participants for the last 4 hours continuously, sir. Thank you. Thank you very much, sir. It's a
Thank you,
great
sir. Because
opportunity.
in previously in my career starting, I worked as a lecturer in some corporate college like Vignan and then Vidwan sort of thing. Because so that is science.
Yeah, it's a great, sir. Great to have you in our session, sir. Very much thankful. Thank you. Thank you very much, sir.
Thank you,
Yeah,
sir. Thank you.
participants, we are going to close the session. Thank you. Thank you very much. Thank you, sir.